松田株式会社の吉岡です。これから2019年度の IVI ワーキンググループの活動内容をご紹介したいと思います。人と物の実績の可視化、分析と最適化というテーマで活動を行ってきました。それではこれより我々の活動内容について説明させていただきたいと思います。どうかよろしくお願いいたします。
I will introduce the activities of the 2019 IVI Working Group 5C03. The theme is Visualization, Analysis and Optimization of Human and Things. The secondary alternative title is Pursuit of Next Generation IE. 10 members listed in the slide worked for about 10 months. I will explain the background and aim of the activity. We made the Pursuit of the Next Generation IE as the alternative sub-theme, and it was the second year's theme activity. IE is an abbreviation for Industrial Engineering. Last year, we worked on the theme of visualization of relief man operation. We are working on visualization and optimization of work for which it is difficult to grasp the actual results by analysis using conventional stopwatches and videos. Recent advances in IoT technology have made significant advances in measurement technology in loss quantification, which is a specialized area of IE. Therefore, this year, we challenge to visualize the movement of forklifts in logistics workplaces, which are common to every companies. In this activity, we thought the important point of this activity is that inexpensive and easy to install for any workplace that is using the forklifts and other logistics equipment, regardless of industry. Therefore, we aim to make it possible to use it in various workplaces without making a large investment by having a device configuration to collect information by each forklift and carrying the device around. We started the experiments with the cooperation of Panasonic Corporation regard to electronic devices such as cameras and PC. Please see the left diagram in the slide. The software draws a flow line on the layout with a red line. The center is the screen of rear view and front view taken by the camera. And, on the right is the dashboard, which displays data from sensors in 0.1 second increments. The first row shows the X and Y coordinates of the forklift. If the forklift moves to the east, you will see increasing the number of X coordinates. If the forklift moves to the north, you will see increasing the number of Y coordinates. The second row is speed information. The sixth row is the information on the load applied to the forklift. It became possible to draw the real-time plotting of moving a forklift, and we could capture the movement of the forklift. The activity members of us, who were unable to enter the operation area due to safety issues, were able to accurately grasp the actual movement of the forklift. This figure shows the forklift position and load information plotted that I explained earlier on a single graph. The horizontal axis is the time axis and is divided every 36 seconds. The left side of the vertical axis is the coordinates of the X and Y axes, and the right side of the vertical axis is the load data. Changes in X coordinate point are shown as a blue line chart, and the changes in Y coordinate point are shown as an orange line chart. Also, the black bar chart shows the changes in load data. The forklift repeatedly moves in the X and Y directions from the coordinates of the cycle start point, that is origin point, and when returns to the origin coordinates, one cycle is finished. This means the starting point of the next cycle. The key point of this demonstration experiment was the graphing of flow lines and load, that is, to create a forklift truck's movement data on the desk. We can identify the working location from the coordinates regarding the actual movement of the forklift. Also, changes in load data have made it possible to grasp changes in parts transportation and empty running. This slide shows the overall picture of our activities, based on the results of the demonstration experiments I have explained so far. The first step is the automatic collection of data on human and objects movements, as I just explained. Based on this automatically collected data, the second step is to perform IE analysis based on the data, that is, visualization of loss. Then, based on the results of this loss analysis, we will consider the improvement plan. This slide shows the result of drawing the flow line in real time that I just explained, arranged by forklift. By visualizing the movement of a day with the flow lines in this way, you can see clearly that there are two types of flow line patterns: forklift 1, forklifts 2 and 3. The main work of forklift 1 is to put the parts unloaded from the truck into the parts shelf. The main work of the forklifts 2 and 3 is to carry the parts taken out from the parts shelf or truck to the line supply area. From now on, I will explain how we analyzed and developed the improvement plan using the visualized data. There are roughly two kinds of patterns: forklift 1, forklifts 2 and 3. Regarding the forklift 1, when we analyze which work zone the forklift is working in, there seems to be patterns for each zone, so we decided to do a detailed work analysis. The forklifts 2 and 3 are moving cyclically all day long, and we analyzed the working time focusing on the variation in working time and each cycle time. First, I will explain the analysis for forklift 1 as zone operation. From the flow line drawing result of forklift 1, basically, it was possible to read from the coordinate data that forklift 1 was working while moving through the 6 zones shown in the upper left. The primary job of the forklift 1 is to put the parts taken off the truck into the parts shelf. In other words, the movement of the zone 1 to 3, 2 to 3, 3 to 4, 3 to 6 are the primary operation. However, it turns out that the operation that took the most time in the day was operation within the same zone, such as 3 to 3 and 2 to 2. Therefore, we conducted a deep dive analysis of the unexpected operation, which is operation within the same zone that makes up 42 of the total shown in red. We analyzed the operation of the first half in the night shift, which is the most characteristic operation in the forklift 1's operation, in detail. During this time period, the forklift 1 had repeated the operation in the parts shelf called 3 zone. Therefore, we analyzed what kind of operation forklift 1 is doing for moving from zone 3 to 3 by looking at the load data. That is the line graph shown on the upper right side. We found that forklift 1 carried parts in double stacking by analyzing how much the load is applied. Since the forklift 1 has a short distance from zone 2 to zone 3, the ratio of transportation time is small. It spent much time for double stacking work and the put pallet on the parts shelf one by one. We confirm that double stacking is more effective for forklifts 2 and 3 because the transportation distance is longer. On the other hand, it was found that the cause of the loss in forklift 1 was double stacking during the short distance transportation. The design of the standard operation is not completed yet. However, during the analysis of the flow line, there was the proposal from one of member, such as if we change the location of parts shelf that forklift 1 is mainly working, the location of the relay station for the parts transfer from forklift 1 to forklift 2 could be changed, and the flow line as shown below could be created to greatly reduce the work time. Therefore, We would like to reflect the results of the loss analysis to standard operation design as improvement viewpoint, and we would like to connect the current operation of 3 people to an improvement that can be done by 2 people. Finally, I would like to talk about the findings from this analysis and future challenges. We have noticed many things. In particular, as you can see in the middle column, by quantify the movement of people and objects, it became clear that what had been investigated and analyzed over a long period of time could be analyzed in a short time with the wisdom of many people. I am confident that this will enable us to implement the PDCA cycle for improvement faster.
ご清聴どうもありがとうございました。今回の活動はワーキンググループメンバーみんなの知恵を集めての活動であったと思っています。本当に素晴らしい仲間と一緒にできたことを嬉しく思っております。また引き続きこの次世代の IE の追求という活動を進めていきたいと思いますので、どうかよろしくお願いいたします。